Okay, our new topic is indices, and the first actually means is that we've seen 6 times itself. 4 times. So if we look at this part here, this part is known as the base. Okay, and this top part, the power. So we could refer to that as the index, or it might be referred to as the exponent, or it might be referred to as the power, a power. Either way, it doesn't matter what you say, but you might need to look out for that in questions. So this, when it's written like this, we call that factor form. And obviously 6 to the power of 4 is 1296. Okay, so any composite number can be written as a product of powers of prime factors using a factor tree. So if you remember back to what a prime factor is a number that is only divisible by 1 and itself. So we can break up any composite number. So when we mean a composite, say for example 100, it's a composite number because I can break it up to be 2 times 50. So if you look there, this 2 is a prime factor because it's only divisible by itself and 1. So, but we can say 2 times 50 is 100. So I've broken it up there. Now I'm going to keep going because I can break this 50 up to be 2 times 25. And then I can break up this 25 to be 5 times 5. So the prime factors here are 2 and 5 and 5. So we can write that, instead of writing 100, we could write it as 2 times 2 times 5 times 5. Because if you think about it, 2 times 2 is 4, times 5 is 20, times 5 is 100. So once we've got it out in that factor form, we can then write it in index form. So because I have 2 2's, and then I can say 5 times 2. Okay, so this is what's known as index notation. So I've just written out the 100 in index notation. Okay, so if we do another one, okay, so if we express 240 as a product of powers of prime factors, so once again we're going to do 2 times 120, and then I can break that one up to 2 times 60, and then I can keep going. 2 times 30 gives 60, then 2 times 15 is 30. Now I can get prime factors of 15 could be 3 and 5. So the prime factors are 2, 2, 2, 2, 3 and 5. So we could write 240 equals 2 to the power of 4 of them times 3 times 5. So this is the index notation of 240. Call it. Okay, so we're going to look at some index laws, and we need to remember that when we have the number down, that the number that the power is on is called, or the letter is called the base, and then when that's called the index, or the power, or the exponent, whichever exponent. Okay, we do have to remember, if you have 3, that 3 actually is 3 to the power of 1. So often that 1's not there, but we should remember that's its power. Okay, the first index law we're going to do is multiplication of indices. So that's when we have an indice of we have the same bases and they've got different powers. So when you multiply two numbers of the same base, you can add the powers. So it'll be m plus n. So this is the first index law. Okay, so you can see if you multiply with the same base, so we can see here these e's are the same base, you can add the same powers. So when I'm working this out, I could write this out as 5 times e to the power of 10 times 2 times e to the power of 3. So if I just rearrange that order, I could write these like that. So if you look, we can do 5 times 2, that's 10. Now because these guys are the same base, we're just going to add their powers. So 10 plus 3, so we end up with 10 e to the power of 13. Okay, with this next example, simplify 2m to the power of 3 times 5m to the